In this screencast, we're going to go through a few more examples of how to index inside of matrices and arrays. Alright, so the first thing that we need to do is actually make a matrix or array. I'm going to call one A, and I'll use the assignment operator, and I'll start making a matrix with the square brackets. So I'm just going to fill it with some random values. It doesn't really matter what these are for the example, but have some values. So 3, 4, 5 in the first row, 2, 1, 8 in the second, and 10, 5, and 2 in the last one. Alright, so when I press enter on this, it shows me this array. Alright. Now if we want to use standard indexing into this array, we type the variable name, which is A, an open bracket, and then we need to give it both the row and the column of the value that we want to look at. So let's say we want to pull out this top left value. It's going to be the first row and the first column. So we get the value of 3. Now, we always start at the top left corner. So 1, 1 is always the top leftmost value. Alright, so if we wanted to look at the second row, so the row is the first value in our index, and the column is the second. So for row 2 and column 3, pull out this value 8, we get the value 8. Now we can use this inside of an expression. So we can add 2 of these values together. So it's going to be the second row, third column, so there's 8, and the first row, second column, 4. So 8 plus 4 equals 12. Next, what we might want to do is pull out multiple values. So let's say we wanted to pull out an entire row. Let's say we want to take out this entire first row. So I'll retype our array just so we can see it. What we can do is A, open parentheses, and we want the first column, and we want the first, second, and third values in those columns. So we look at the first row, and we'll return the first, second, and third values. So this should give us the entire top row. And that's what it does. Right, so our answer here is actually a vector, and we've pulled out that entire vector. Now, as shorthand, we can do something like this. So we can go 1 to 3. So this is our shorthand vector notation, and that works in exactly the same way. Now, this is useful when we just want to pull out, say, just part of a row or a column. We can just pull out those values, or we can even pull out a sub-array, so we've pulled out the top left corner of 4 values. So we can always pull out little parts of an array. Now, if we always just want to pull out a single row or column, what we can do is just put a column there. So this means all of our values. So if we press enter on this one, we can see we're pulling out all the rows of the first column. So that's just going to be the first column here. And 3, 2, and 10 are the values that we get. Right. So we also have some other shorthand that we might as well teach you now. End is a keyword, and what that will do is pull out the last value in that. So that will be the third row. So if we look at end to end, it should pull out the bottom rightmost value. Okay, and that's what we get. So we don't always need to know the size of this array to pull out the last value. We can just use the keyword end, and we can do things like end minus 1 and end. So that will give us the second last row and the last column, which is the value 8 here. Alright, so keep practice all these shorthands, make your own array, play around with it, and knowing these shortcuts can save you a lot of time. So clearing my screen, and just pull up this array again. Instead of just giving it a row and a column, we can use what's called linear indexing. Now, linear indexing is where we've got a 2D array, but we use a one-dimensional index into it. And how this is actually stored on the computer is that this first column is stored first, then the second column is stored after it, and this third column is stored after the second one. So on the computer itself, it looks like just a one-dimensional array, and MATLAB just knows that it's going to be a 3x3 because that's how we defined it. But we can index it like it was a 1D array. So using just a single value, A1 will give us the top left value, A2 will give us the second value, A3 will give us the third value, if I put my brackets in, A4 gives us the fourth value. Now, pull this back up so we don't have to scroll everywhere. So if we look here, the fourth value is 1, 2, 3, 4, and this is the fourth value here. Now, the fifth value is a 1. So as you can just see, this this column here is pretty much just hiding down here, and we can index into that in a linear manner. Right. So sometimes this might be useful, just always keep it in mind. Okay. So it's just another way that we can index into it. Now the final way to index into a matrix is called logical indexing, and that's where we provide a logical array that's the same size as the original array and use that as an index. Okay, so we've already seen using arrays to index into an array, and that will pull out multiple values. Logical indexing is largely the same. We're just using another array to index into this array. So I'm going to call TF my logical array, and logical is a function that converts a regular array into a logical array. Okay, so 1, 0, 1, 0, 0, 1, 1, 1, 0. All right, so we'll see this in a second what it looks like. So we've got true, false, true, false, false, true, 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 false. All right, so what logical indexing does is all the positions where this is true, it will take those values and return them, and it'll return them in the order of linear indexing. Okay, so it'll return this value, then this value, and this value, this value. Okay, so A at the positions of TF gives us 3, 10, 5, 5, 8. So 3, 10, 5, 5, 8 in that order. Okay, so logical indexing is quite a nice little tool. It might not seem useful now, but we can actually generate these logical arrays quite quickly. So let's say we're looking at the matrix A, and we want to find the values of this matrix that are greater than 5. So it would be this 10 and this 8. All right, so what we can do is type the array name, greater than symbol, and then 5. And this returns the logical array where that is true. Okay, so we can now use this resultant array as an index into A to pull out those specific values. So pull out A again. So A, where A is greater than 5, pulls out 10 and 8. Right, so that one is logical indexing. And those are our three main types of indexing into arrays, so that's just our standard indexing, linear indexing, and logical indexing. Try to master all three. They're very useful in different situations. Thank you.